Hi everyone. So today I will be discussing unconstrained optimization problem in nonlinear programming problems. So actually last class we have discussed that there are different types of nonlinear programming problems. One is unconstrained optimization, then linearly constrained optimization, then quadratic programming. So in this way there are various types of nonlinear programming problem, but we will start with unconstrained optimization problem. So what is the unconstrained optimization problem? We'll see. So let us start with one example, then it will be much easier to understand. So take an example. Maximize fx is equal to 3x to the power 4 minus 4x to the power 3 minus 24x square plus 48x plus 15. Now you see here, this is a problem. The type of this problem is unconstrained optimization of one minute. Okay, so I have taken one example, that is maximize this function. So which kind of, this is a non-linear function. We can see that it's not a linear function, it is a non-linear function. As you can see, the exponent of x, that is 4 here, it's 3 2, so maximum exponent is 4, which is greater than 1. If maximum exponent is 1 or 0, then that is known as linear function, but here it is 4, so it's a non-linear function. So the we have to maximize this non-linear function. So what is the type of this function? It's unconstrained optimization of non-linear programming problem of one variable. So we are talking about unconstrained optimization of non-linear programming problem of one variable. So here you can see there is only one variable, that is x. So we will start with one variable, then we will go for 2 variables, 3 variables and 4 variables, like that. So first we will see that the simplest one is one non-linear programming problem, and it is unconstrained. Unconstrained means there is no restriction of x, like x can vary from minus infinity to infinity. So see here, if we take this axis, So here this is 0, this is 1, 2. So on this axis we will put x. So x is not limited, it is like it can vary from minus infinity to infinity. So what will be the value of x, fx? So we have, let's suppose fx, we don't know how it will look like on the graph. So fx, if we draw on the graph, how it may be like, it may be something like this, let's suppose. So we have to find maximum of fx in between x minus infinity to infinity. That means x has no restriction, x can go up to infinity or x can go this side up to minus infinity. There is no restriction in that. So in that range we have to find maximum value of fx. So that is known as unconstrained, means there is no restriction of the variable. This x is the variable, so it is not having any restriction from where to where it will go. That means it will go up from minus infinity to infinity. So it may be written here like the may be given like this, that maximize fx is equal to 3x to the power 4, like this, for all x. It will be written for all x, for all x, like this also it may be written, x belongs to real number. Okay, for all x real number. This is also a unconstrained optimization because x is a real number. Now real number can be on the number line, it will be from minus infinity to infinity. Okay, or it may be written for all x lying between minus infinity to infinity. So these two is giving the same like same indication that x is unconstrained, means is varying from minus infinity to infinity, means there is no restriction in x. Okay, sometimes you will find in some questions it will be written x is minus 4 to 4, something like that. Okay, so what is there? So x is constrained here, it's a constraint. Restriction is there that x cannot go beyond 4 and x cannot go beyond minus 5. So this will be known as constraint. But if it is written minus infinity to infinity, then it is unconstrained. So that we have to understand while solving the problem, that it is a constraint or unconstrained problem, we have to decide. So now we have to solve this one. So let me erase this all. So I think in your first semester, like you have also studied about this, that how we find the maxima minima of this function. You know, if you like you have studied this one. If you have forgotten, there is no problem, I'll discuss this one. Let's see, fx is given. So what we were doing, just to calculate maxima minima of this function, we were calculating f dash x, f prime x. Okay, so f prime x will be 12x cube minus 12x square minus 48x. I am differentiating this with respect to x, 48, and this is constant, so it will be 0. So this is the value of fx, f prime x. Now if we want critical points, so what I have to do to find critical points, means critical points means the points where you need to, you will be getting either maxima or minima. So that points are known as critical points. To find critical points, equate f prime x is equal to 0. If you equate this one equal to 0, you will get, see, 12x cube minus 12x square minus 48x plus 48 is equal to 0. You can see 12 is common here, so I will be removing that. I will be getting this much. Oh, sorry. this is x, and this is 1 is equal to 0. Oh, 4x, this is 4x and this is 4. So now you can see here x minus 1, here also it is common. So what I will do, I will take out x minus 1 common from here, so it will be remaining x square, and here minus 4 is taken out, then it will also remain x minus 1, this is equal to 0. Now x minus 1 is taken out, then it's remaining x square minus 4 is equal to 0, and this will give you x minus 1, x minus 2 and x plus 2. If you just break this one, you will get this. From here what we are getting, what are the values of x? So from this we are getting that f prime x is equal to 0 for which value of x? X is equal to 1. If this is equal to 0, then x is equal to 1, x is equal to 2, and x is equal to minus 2. So on these points you will be getting f prime x is equal to 0. So these are the critical points. So these are the critical points. Now we have to check on these points only that whether this function has maxima on this point or minima on this point. So we will check in let's check here. Okay, so for checking that whether it is maxima or minima, what we need to calculate? We need to calculate f prime x. So that means we have to differentiate this one once more with respect to x. So it will come 36x square minus 24x minus 48. This is now we will check. So at 1, if you put x value 1, then what is the value? It's coming 36 minus 24 minus 48. It's a negative value. It's a less than 0. Just calculate. So that means if f double prime is coming less than 0, so you will be getting what at this point? You will be getting maxima at 1. Okay, take the next point, next point, that is equal to minus 2. First check it. So this will be 36 into 4, that is 144, minus 24 minus 2, that is plus 48, and minus 48, that is greater than 0. So greater than 0 means you will be getting here minima. So at this point you are getting minima. Now next point is f double prime 2. On 2 what you are getting? So 144 minus 48, 24 into 2, 48 minus 48. So this is again it's a 96, so obviously it is greater than 0. So here you are getting minimum. Okay, so now at every point we have checked, and we found that at x to 1 we are getting maximum, at x is equal to minus 2 we are getting minima, and at x is equal to 2 we are getting minima. So here question is maximize this one. So maximize this one means obviously we are getting maximum at x is equal to 1. Now can you calculate the value of f at 1, how much it is coming? So I will just remove this part. Okay, so what I'm going to do, I'll check that what is the value of 1. Actually it is written maximize this, means what is the maximum value of fx. So maximum we are getting at 1 only, so obviously maximum value of fx will be how much? 3 minus 4 minus 24 plus 48 minus plus 15, that is how much? Around this is 28, 20, 23, 38. So this is the maximum value of fx. Okay, now so why okay, while solving this there are many concepts which is to be cleared now to understand. Okay, what is maxima, what is minima? So first of all, what we will do, we will draw a curve of this function. We will draw a curve of this function, how fx looks like. See, it is if it has been x square, then it would have been very easy to draw this curve, but when it is x to the power 4, it's really difficult to draw. Okay, so but still we will see that how it looks like when you, so just take the coordinates and name it, this is x here, and on this curve we are taking, on this axis we are taking fx. Okay, so this is 0, and the points which are critical are 1, -2 and 2. That means it's just nearby origin. So just take these 2 points, take -3 also here, 1, 2 and 3. More is not required now. So you can see at f1 it's 38, that means somewhere here. Okay, now at -2 what is the value of fx? So just take f -2, what is the value? Just put -2 here and calculate fx value at -2. So it will be 4, 4, 16, 48 minus plus 8 and 4, 32, 4 minus 96, minus 96 plus 15. How much is this? Let me calculate. 48, 32, 96, 96 plus 15, minus 97. This is coming minus 97, means that means at -2 it is coming just here somewhere. You see, this is 1 point, this is 1 point. So here it is minima, you check, -2 it is minima, that means it's here at this point, and we are getting maxima at this point. And what about 2? So just check f2 is equal to this is 48 obviously, and what is this one? This is minus 32. What is this? 90 minus plus 96 and plus 15. How much it is? So this cancelled. 48 and 15 is 63 minus 32. That is 31. So it's coming 31. This is 38. You check. This is 38. So 31 will be somewhere here at 2. This is 31. So this is the point. Okay, so 3 points we have got. So it is written that it is told that at 1 it is maximum. Means do you know how a curve looks at maximum? So see, the curve here, where is the maximum? At this point is the maximum. We can say easily that this is the maximum. That means at this point the curve nature will be like this one. It's like this. Okay, now it is told at -2 the curve is minimum. So minimum means it should be like this. So at this point it is minimum. So here the curve will be like this. Now at 2 it is also minimum, that is 31. So here the curve will be like this. Okay, so we are getting minimum here. Now just join this curve. Okay, and it is going somewhere here and it's going somewhere. So now we can see the curve. So this equation is now, it's plotted here and it looks like this. We are getting at this point is maximum, at this minima, and this is minima. Okay. So 3 points we got. So this is the curve of this function. Now some concepts again we have to see, that is okay, little bit I will remove this one now. Okay, so check, look at this. So some of the things which are required to be understood, what is the meaning of a convex function and concave function. Okay, so that we will understand from here. So okay, from this curve, one is first point, that is convex function. Which function is known as convex function? We will tell that why I am talking about this concepts, what is convex and what is concave. So convex function means, just remember, a function which is convex from downward, that is known as convex function. Any function which is convex from down. So let's suppose this is a function. Okay, this is the diagram of a function. So from down you have to check, okay, from below, that whether it is a convex, it's looking convex or concave. So you see, if you are looking from down, then it is looking concave, so it will be a concave function. This one is from below, if you check, then it is looking convex. Okay, so that will be a convex function. So that is the definition, that's all. This much only you remember, it's very easy to remember this one, so that's why I have given this one. Second is concave function. Concave function means it will be convex from concave from below, concave from downward, just like that. So नीचे से देखना है. Okay, and so here it check. So here the function is concave or convex. So from below you have to check. So it's from below, if we see, then it is looking like concave, so it is a concave function. Okay, so from this range to this range, the function is concave function, and from here to this onward, it is a, from below if you see, then it is a convex function, and at this point also, from below if you see, then it is convex function. Okay, so here in this range it is convex, is in this range it is concave, and in this range it is convex. Clear? Now what is the condition of concave and convex? So here we have got f double dash f double prime is less than 0 or greater than 0. We have got greater than 0. Are you getting? So this is a convex function. So what is the condition for convex function? F double prime x should be greater than 0. So this is the condition for convex function, that is f double prime x should be greater than 0. This is a concave function. Okay, and for maxima what we get? F double prime x less than 0. So this is the condition for concave function, and this is also convex function, and we have got here at this point f double prime x is greater than 0. So this we have to remember. Convex function means convex from below. You have to check convex from below. Okay, so if the curve is like this, something like this, then it is, if you see, then it is convex from below. So this is a convex function, and the condition for it is f double prime x should be greater than 0, and this is concave function. Okay, from below if you see, then it is a concave function, and its condition is f double prime x should be less than 0. Okay, so if the function is concave, means here, then what is the chance of getting maxima or minima? you can get maxima. So if you come to know that this function is concave function, then you will think you can include that you will be getting maxima there. ओके ये कॉन्सेप्ट हमको आगे में यूज आएगा, इसलिए मैं बता दे रहा हूँ, ठीक है, कि कनकेव फंक्शन अगर है तो आपको यहाँ पे चांस क्या है, मैक्सिमा मिलने का चांस है, मैक्सिमा एट ए पॉइंट इन दिस रीजन। इस रीजन में अगर ये फंक्शन कनकेव है तो यहाँ पे आपको मैक्सिमा मिलेगा, ए पॉइंट इन द region. Which region? In the region of concave function, and here we will be getting minima at a point in the region of convex function. Clear? So this is important point. If we come to know any function that in this range this function is concave function, then that will be known as कनकेव फंक्शन मीन्स मैक्सिमा मिलेगा उस रीजन में, ठीक है, तो आपको उस रीजन में चेक कर लेना है। और अगर आपका कन्वेक्स फंक्शन है तो उस रीजन में आपको मिनिमा मिलने वाला है, दैट यू विल चेक। नाउ this concept is over, so I'll just remove that. Okay, this I will just delete. Now there is a concept of local maxima and local minima, global maxima and global minima. Okay, so what is local maxima, what is local minima, what is global maxima, and what is global? So we will see that. So local maxima, okay, so you see that in this curve how many maxima and how many minima are there. So at 2 points we are getting minimum value, here also and here also, minima, okay, but among them which is the which is the, you can say, the lowest one. So this one is the lowest one, so this will be known as global minima. Okay, this will be known as global minima. So we are getting local minima at x is equal to -2 and 2, but global minima where we are getting at x is equal to -2. Clear? Because that is the lowest. Similarly, local maxima where we are getting at x is equal to 1. See, we are not checking on the end points. Why? Actually we need to check on the end points also, but here there is no end point. Why? Because x is going to infinity and this side also x is going to infinity, so there is no end point only. Where you will check? We don't know that where it will be going and ending, so we don't know at all. If it is a constrained function, then we have to check on the end points also, because let's suppose if the end point is this one, somewhere 3, then this will be the max. This is one local maxima, this is another local maxima, and among them which one is global? So this one is global. Okay, here you see minimas. So here maximas are 3. See here also maxima is there. Okay, this is one maxima, this is another maxima, this is another maxima. There are 3 maximas. Out of this, these are local maximas. Out of this one is maximum out of all, then this will be known as global maxima. But and here you see minimas, so one minima and another minima. Out of this, which one is the minimum of the lowest? This one will be becoming the global minima. So local maxima is only at x is equal to 1 right now, so that's why this also will become global maxima. So global maxima will be at x is equal to 1. Okay, so this concept is another one which you take the note of. So these are the some of the concepts which we will be seeing later, because it is an easy example. So with this example I am talking all the concepts, okay, with and later when the problem will be, you know, constraint optimization and all, and 2 variables, 3 variables, 4 variables, there you have to use the same concept, okay, and we will solve those problems. Okay, so this is another done. So we have seen, we have solved the problem, but we haven't uh, you know seen the what are the, you know, conditions, like how to check that it is maximum or minimum. So already we have solved it, so just we will note it down, what are the different conditions of maxima and minima. Just so I'll clean it. So let's start. What is the necessary condition for optimality? Necessary condition for optimality. Optimality means either maxima or minima. So what is the necessary condition? So necessary condition is that a function fx, we have told that what is the necessary condition. First condition is f prime x should be equal to 0 at x is equal to x star. That is first thing. This is the necessary condition, that at x is equal to, at certain point the function should be equal to 0. Now there is a condition, what, that this function should be defined at x is equal to x prime, differentiable at this point. Are you getting? The function should be differentiable at this point, means, are you getting? It should be continuous. Okay, so the function is should be differentiable at x is equal to x star. Then only we can talk about whether you will be getting maximum or minimum. Clear? So that's why we have seen, when I was solving, let's suppose this is the function. Clear? Now can you tell me where you are in this just graph? You just check it. Here there are certain points. Okay, this is point number A, point number B, C, D and E. Can you tell me where you are having maxima and minima? So we have local maxima. First we will see local maxima at this point B. Here it is minima. This is we don't know it's maxima or minima. At this point E, B and E, and local minima at A, C, A and C, and D actually is the saddle point. Saddle point means we don't know it's a maxima or minima. Actually it is not a maxima, neither maxima nor minima. Neither maxima nor minima. Okay, so these are the three things. So you see, this actually is a point where the curve is changing its nature. this is the it's a from downward, if you see, then it's concave. So this is concave, and after D it is, if you see, it's convex. So at this point the function is changing from concave to convex. But you see at C, from downward, you see it's a always convex function. So at C it is convex function, at B it is concave function. Okay, so but here we cannot say because it is changing from concave to convex. So the point at which the function changes its nature from concave to convex or convex to concave, that point is known as saddle point. So there you don't get maxima or minima. Clear? Okay, so now we are getting local maxima at B and E and local minima at A and C. Okay, so but as we have seen in this example that we were not able to get these points. We were able to get which points? This point, where differentiation f dash x is 0. So here is the f dash x 0 because the curve tangent is parallel to the x-axis. This is x-axis, so parallel to x-axis. So here f dash x is 0. So these points, and here also actually this is also f dash x is 0. So at you will be getting, when you know, if you differentiate this function, if this is a fx function, if you differentiate this function, you will be getting 3 points, that is B, C and D. You will not get A and E. Okay, so B, C, D you will be getting, and because here the function is differentiable, here also function is differentiable, here also function is differentiable. The function is not differentiable at this point and at this point. So these points you will not be getting. Okay, and you will only be able to get that. Okay, here you are getting maximum, here you will be getting minima, here you will be getting maximum. What about this point? Here you are getting maxima, isn't it? Here you are getting minima. Now can you tell me which one is global maxima? Yes, this is global maxima. And which one is global minima? This is global minima. Okay, but when you are solving through this method, you are getting maximum, global maxima at this point and global minima at this point. So what is happening? You are here the this method is not working. So that's why it is so just I'm taking one disadvantage, or you can say drawback of this method. This method is known as analytical method. Okay, so we will see on another method also of solving non-linear programming problem. So we are just discussing right now analytical method. Analytical method means where we use differential calculus. Here we are using differential calculus. Using differential calculus we are solving the problem. So what is the method? First we calculate first order derivative, that is f prime x, we equate it to 0, and then we calculate the we find out the critical points. On critical points we check f double prime x. What is the value of f double prime x? Means double differentiation, and if it is greater than 0 we will get minimum value, if it is less than 0 we will get maximum value, if it is equal to 0 we will see. So this is the necessary condition. Let's see the sufficient. Actually once it is necessary condition f double prime x is equal to 0, here we cannot say, this is the drawback of this, not drawback, or you can say limitation, just limitation. Okay, so necessary condition means it must be fulfilled, but this is not the sufficient condition, because we cannot say that you know, we can't say that x is equal to x star will be minima or saddle point. We cannot say that. So for that we require sufficient condition. So we require sufficient condition for optimality. So what is the sufficient condition for optimality? We have discussed. What is that? F double prime x. Wait a minute. So what is the sufficient condition that we'll say? That let f prime x equal to f double prime x is equal to f triple prime x is equal to, and so on, is equal to f n minus 1 is equal to 0. Okay, at x is equal to x prime, and f n x is equal to is not equal to 0, then x is equal to x star is a what, maxima or minima? So first condition, that it will be local minima if f n x star is greater than 0. Okay, and n is even. Second, it will be local maxima if fn x star is less than 0 and n is even. N has to be even, then only we can tell it is maxima or minima. But what if n is odd? Then a point of inflection n is odd. So this is the sufficient condition of optimality. For optimality, sometimes it may happen that f prime x you have calculated, from here you have calculated the critical point, like that is x is equal to x star, the values of x star, as in previous it was 1, 2 and minus 2. Here we have calculated. After that you put it into x double prime x and you found that x double prime x is also becoming 0. Then that time what you will do? Then you have to go for this f triple prime x is equal to, calculate that value. If that also comes 0, then calculate f 4 prime x is equal to how much. So like that, go on checking. That's why I have when I went to n. So you have to find out this not equal to 0. Once you found not equal to 0, then that will be local minima. Then at that point you will be getting local minima if f n prime x star is greater than 0. जैसा n is even, मतलब if this is double prime greater than 0, जैसा same था, local minima मुझे मिल रहा था. Same case here also. Okay, so in this way this is the method of calculating. If it is 3, let's suppose this is 2 is equal to 0, but 3 f3 prime x becomes not 0, then that becomes, that point is a saddle point, it's a point of inflection where you will not get maxima or minima. Clear? So based on that we will solve 1 or 2 problems, and then in next class we will talk further about different other concepts. So let's see one problem, one example. Find maxima or minima, or just check optimality, that is better, so just remove this one and write question as check optimality of fx is equal to x to the power 5 by 5 plus x to the power 4 by 4 minus 5x cube by 3 plus 3x square by 2. This is the problem. So first you have to check both necessary condition and sufficient condition. So let's go for f prime x. How much it will come? Differentiate it. 5x to the power 4 by 5 means x to the power 4. This is 4. 4 cancel, so x to the power 3. This is how much? 3 will be cancelled, so 5x square. Here 2 will be cancelled plus 3x. Just you differentiate by yourself. So f prime x is calculated. Now what I will do, I will just factorize it. So x cube plus x square minus 5x plus 3. Now this type of function, if it comes, it's actually a little bit difficult. That is the one limitation of differential calculus, that factorization becomes very tough, of higher degree. If the function is of higher degree, like here it is 3, in the last problem it was 4, so in that problem it was much easier, so that's why they could do. But here it's 3. Now how you will factorize? So anyway, we will not waste time and we will just go. What I'll do, x, I think it is 3. 3 is the common, so x plus 3 is common from here, so here it will be x square. So this is 3x square, so minus 2 x. Okay, so it will be x, and how much is this? Minus 2x, so obviously plus 3, so it becomes minus 6x, so plus x plus 3. Okay. So x plus 3 is common now, you can see. That is the difficulty of this type of so x plus 3 is common, and now it is x square minus 2x plus 2 plus 1. So x minus x plus 3, how much is this? Factorize, this is x minus 1 square. So now if f prime x is equal to 0, then what is the value of x? X will be 0, this one, and x will be minus 3, or x will be 1. At all these 3 points, f prime x is 0. If you put x is equal to 0, this becomes 0, the f prime x is 0. If you put x is equal to minus 3, this becomes 0, this will x is equal to 1, you put it here, it total will become 0. So these are the you can say critical points we have got. These are the critical points. Okay, now we need to check f prime double prime x. F double prime x is equal this is the 4x cube plus 3x square minus 10x plus 3. So at just leave that. F double prime 0, first check at 0, 0, 0, 3. It's 3 greater than 0, that means minima. You are going to get minima. F double prime minus 3, how much? Minus 27 into 4, it's 27 into 4, 108, so minus 108 plus 9 into 37 27 plus 3. Obviously it is less than 0, so it is, we are getting maximum here. F double prime 1, at 1 what is the value? 4 plus 3 minus 10 plus 3. Oh, this is becoming 0. Okay, if it is becoming 0, so what I have to do? In the sufficient condition, remember that we have to go for 3 prime. So calculate 3 prime. So first of all, calculate f triple prime x, that is 12x square plus 6x minus 10. Now calculate f triple prime 1. Then you will get 12 plus 6, 18, minus 10, 8, which is greater than 0. Actually, this is not equal to 0. It's told that if fn x is not equal to 0 and n is odd number, here it is 3, which is odd number. If it is not equal to 0, that means it is a saddle point. So at 1 we are getting saddle point. So here we have got maxima, here we have got minima, here we have got saddle point. Now we can see the curve also. So for that we require to put the values of x here, and we will see the how this function is behaving. Okay, so in the next class we will check that, and for today I'll be giving you one problem in the quiz. You just try to solve that problem and check that at what point you are getting maxima, at what point you are getting and all that. In next class we will solve these same problems with the help of MS Excel sheet. Okay, and you will see that it becomes so easy, because I told there are limitations of this differential calculus. Like you saw here that it was really difficult to factorize this one, and we have also seen the end points problem. end points पे ये differential calculus में आप नहीं पता कर पाते, ठीक है। तो ये सब limitations के कारण से एक दूसरा मेथड है, that is known as numerical method. so analytical method, दो मेथड हो गया, एनालिटिकल मेथड जिससे हमने अभी सॉल्व करना सीखा है, और दूसरा है न्यूमेरिकल मेथड. In engineering, actually numerical method is used a lot of, in researches. This is the mostly used method, numerical method, and it's it becomes very easy because analytical method has a lot of limitations. You can, as soon as it comes sin x or log x, you will be stuck, you cannot solve that. Analytical method will be failed, so there you have to go for numerical method. Okay, so we will see the glimpse of numerical method by MS Excel. We will solve the same problems with MS Excel in the next class. Okay, so by the time you can try to solve the quiz which I am going to give in your email, you will be getting. Thank you very much. So I'll stop here.